Hello everyone, in this video we are going to discuss exercise 2.2 of chapter 2 polynomials. The first bit is find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. In the first bit, the first question is x square minus 2x minus 8. The first step we need to do is multiplying the constant with the x square coefficient. Here the constant is 8, multiplying that with x square coefficient. Here before x square nothing is there, so it means 1. 8 ones are 8. Actually in the question the constant is minus 8, but if we take the minus, again a problem comes, so that's why I didn't take the minus symbol. In the next step I will explain how to use the symbols properly. Now constant is 8 and x square coefficient is 1, so 8 ones are 8. Now write where 8 table will come. 1 8s are 8, 2 4s are 8, again 4 2s are 8 ones are. So only two pairs are possible. In the first pair we have a number 1 and number 8. In the second pair we have number 2 and number 4. Now this last term or else constant, negative symbol is there, right? That negative symbol will decide that in this pair 1 and 8 one number is compulsory negative. In this pair 2 and 4 compulsory one number is negative. That will be decided by the constant symbol. Next, middle term symbol. For middle term, which symbol will be there? The same symbol we need to keep for the biggest number in the pair. Here first pair is 1 and 8, right? 8 is biggest, so keep negative symbol. In the second pair 2 and 4, 4 is the biggest, right? So keep negative symbol. Okay, now let us check these pairs now. Here we have 1 and minus 8, right? 1 minus 8 minus 7. Second one 2 and minus 4, right? So 2 minus 4 minus 2. Here the middle term is minus 2. So this pair, second pair is the correct pair. Just try to understand this. If you did not understand, just wait for the second question also, so that you may get one clarity how to solve it perfectly. Okay, now first term x square as it is. Second term minus 2x we need to replace with this pair. Plus 2x minus 4x minus 8 as it is. Now from the first term and the second term we can take out x common. So if we take out x common, then we replace with x plus 2. So x into x is x square and x into 2 is 2x. Now here also whatever you got inside of the bracket, write the same as it is, x plus 2. Now observe the third term. Here the third term is minus 4x, right? Already inside of the bracket x was completed, so remains with minus 4. So now here if we observe this clearly, here x plus 2 is there, here x plus 2 is there, write one time x plus 2 into here outside extra x, here outside minus 4. So finally the factorization is x plus 2 into x minus 4. But we want zeros, right? So simply change the symbols here. X plus 2 is there, right? So x value will become minus 2. X minus 4 is there, right? So x value will become plus 4. So minus 2 and plus 4 are the zeros of the given quadratic polynomial. Then he is asking to verify the relation also. So let us check that one, how to solve. 1 0 you take it as alpha and 1 0 you take it as beta. Here minus 2 I am taking as alpha and plus 4 I am taking as beta. You can take in reverse also, no problem. Then we need to find out the sum of the zeros as well as product of the zeros. Here sum of the zeros, both the zeros we need to do addition. Alpha is minus 2 plus beta is 4. Minus 2 plus 4, 2. Alpha into beta, alpha is minus 2 into beta is 4. 4 into minus 2, minus 8. Now this one we need to compare with minus b by a value as well as c by a value, because alpha plus beta, that is sum of the zeros, formula is minus b by a. Alpha into beta, that is product of the zeros, formula is c by a. Coming to the next question. 4s square minus 4s plus 1. The first thing is multiplying the constant with the x square coefficient. Here constant is 1, so 1 into x square coefficient 4. Here instead of alphabet x they give s, so both are same, no problem. 1 4s are 4. Now 1 will come in which tables? We need to write all those. 1 4s are 4 and 2 2s are 4. Now as I said already, the constant symbol decides the symbols of pairs. Here constant symbol is plus, right? So it means in both the pairs, 2 numbers are positives, otherwise 2 numbers are negatives. And this middle term will be decides both the symbols are negative. So here in every pair both the symbols are negative, both the numbers are negative. -1 -4, -2 -2. So again I will say, if the middle term is negative and the last term is positive, in the pair both the numbers are negative. So -1 -4 is -5 and -2 is -4. So the middle term is -4, right? So second pair is the correct pair. This is the pair we required. So write the first term 4s square as it is. -4s can be replaced by -2s plus 1 as it is. Now from the first term and the second term we can take out 2s common, then remains with 2s minus 1. Next, here also write the same again, 2s minus 1, and observe the third term in that. Third term is minus 2s, right? Already 2s I wrote inside of the bracket, then write the minus symbol here, nothing but minus 1. So inside of the brackets 2s minus 1 is there, so write it once, 2s minus 1 into here extra 2s, here extra minus 1. So the factors are 2s minus 1 into 2s minus 1. Then these are the factors, right? Then we need to find out the zeros, right? So it's very simple. Alphabet s is equals to, here minus 1 is there, right? Plus 1. Here multiplied by 2 is there, right? Divided by 2. S equals to, here minus 1 is there, so plus 1. Here multiplied by 2 is there, so divided by 2. So the zeros are 1 by 2 and 1 by 2. Let us take alpha and beta now. Alpha value is 1 by 2 and beta value also 1 by 2. Now we need to find out first sum of the zeros. Alpha plus beta equals to 1 by 2 plus 1 by 2. Here both the denominators are same, so let us add the numerators. 1 plus 1 by 2. That is 2 by 2, nothing but 1. So the sum of the zeros is 1. That can be written as minus b by a. Next, coming to the product of the zeros, alpha into beta equals to 1 by 2 into 1 by 2. Multiply both the numerators, 1 1s are 1. Multiply both the denominators, 2 2s are 4. This should be equated to c by a. Alpha into beta, product of the zeros formula is c by a. Coming to the question number 3, 6x square minus 3 minus 7x. The previous first two questions, if we observe properly, and this third question, if we observe properly, we will get to know one thing, that in the first question as well as in the second question, the question is in order. It means first x square will come, then after x will come, then after constant will come. But coming to this third question, that is missing. First x square, okay, but second constant is there. Actually second should be x coefficient, then third should be constant. So there it is not in standard form or general form. Let us make it to standard form now. First term should be x square, right? So 6x square. Then the second term should be x, right? So minus 7x. Third term should be the constant. So we got it as 6x square minus 7x minus 3. Now let us do our process. Constant 3 multiplied by x square coefficient 6. 3 6 are 18. 18 will come in which tables? We need to write all those. 1 18s are 18. 2 9s are 18. Sorry, 3 6 are 18. And in reverse, 6 3s are 18. 9 2s are 18. 18 1s are 18. Only 3 pairs are possible. Now here constant is negative, right? So if the constant is negative means in every pair one number is compulsory negative. In this pair also one number is compulsory negative. In this also one number is compulsory negative. And the middle term is negative. So in every pair the biggest number is negative. In 1 and 18 is bigger, so that should be negative. 2 and 9 is bigger, right? So 9 should be negative. 3 and 6 is bigger, right? That should be negative. Now let us do calculation of this. 1 minus 18 is minus 17, and 2 minus 9 is minus 7. 3 minus 6 is minus 3. Here the middle term is minus 7, right? So this second pair is the correct pair. Write the first term 6x square as it is. Minus 7x should be replaced with plus 2x. Minus 9x. Minus 3 as it is. From the first and the second terms we can take out 2x common, then remains with 3x plus 1. Again here also we need to get the same inside of the bracket 3x plus 1 only, and observe the third term. Here third term is minus 9x, right? Already I completed 3x inside, so write minus 3 here. Now 3x plus 1 2 times is there, just write it once. 3x plus 1 into here 2x is extra, here minus 3 is extra. So finally the factors are 3x plus 1 into 2x minus 3. Then we need to find out the x values, right? So let us do that one. X is equals to, here plus 1 is there, so it becomes minus 1. By here multiplied by 3 is there, so here it is divided by 3. Then x is equals to, here minus 3 is there, so it becomes plus 3. By here multiplied by 2 is there, it will become divided by 2. So the zeros are minus 1 by 3 and 3 by 2. Let us take one as alpha and one as beta. Alpha value I am taking it as minus 1 by 3. Beta value I am taking it as 3 by 2. As I said already, you can take in reverse also, no problem. Same answer you get anyway. Now first let us find out the sum of the zeros. Alpha plus beta equals to minus 1 by 3 plus 3 by 2, which is equals to, let's do cross multiplication. Minus 1 2s are minus 2. Here plus symbol is there, so plus 3 3s are 9 by 3 2s are 6. Now 9 minus 2 7 divided by 6. That we need to make it equals to minus b by a. Then product alpha into beta equals to minus 1 by 3 into 3 by 2. That is equals to, here 3 cancel, then remains with minus 1 by 2. That we need to equate to c by a. Coming to the question number 4. 4u square plus 8u. Now if we observe this clearly, in this constant is not there. So when constant is not there, only x square and x will be there, means how we need to do them. From these two terms 4u square plus 8u, we can take out 4u common. Then we will remains with u plus 2. Now this is one term 4u and this is second term u plus 2, right? Both make equals to zeros. 4u is equals to 0 or else u plus 2 equals to 0. Now 4 if we take to the another side, it becomes a division. So u is equals to 0 by 4, that is 0 as usual. Then here u plus 2 if we take another side, it becomes minus 2. So u value is minus 2. One is 0 and one is minus 2. One take it as alpha and the another alpha is 0 and take the another number as beta. Beta is minus 2. Now let us do sum of the zeros. Alpha plus beta equals to 0 minus 2, that is minus 2. Make it equals to minus b by a. Product of the zeros alpha into beta equals to 0 into minus 2. That is 0 into anything is 0. Make it equals to c by a. Next question is t square minus 15. Here x coefficient or x term is missing completely. Square is there, constant is there, but x is missing. So what we need to do is t square minus 15, make it equals to 0. Take minus 15 to the right side, so that will become plus 15. T square value is 15, then what will be the t value? Plus or minus root 15. One take it as alpha and one take it as beta. So alpha I am taking it as plus root 15 and beta I am taking it as minus root 15. Now let us find out the sum of the zeros first. Alpha plus beta equals to, alpha is plus root 15 and beta is minus root 15. Plus root 15 minus root 15 both will cancel, then it will be equals to 0, and this alpha plus beta make it equals to minus b by a. Then coming to the product, alpha into beta equals to plus root 15 into minus root 15, that is equals to plus into minus minus root 15 into root 15, 15. This alpha into beta we need to equate to c by a. Coming to the next question, 3x square minus x minus 4. In this x square term is there, x term is there, as well as constant also there, and that too, that is in general form, correct, standard form. X square is first, then x, then constant. So first thing what it is, multiplying the constant with x square coefficient, right? So here constant is 4 and x square coefficient is 3. So 4 3s are 12. First write where 12 will come. 1 12s are, 2 6s are, 3 4s are in reverse, 4 3s are, 6 2s are, 12 1s are. Here the last term is negative. It indicates that in every pair compulsory one number is negative and middle term is negative. So that indicates that in every pair bigger number is negative. 1 and 12, 12 is bigger, so negative. 2 and 6, 6 is bigger, 6 is negative. 3 and 4, 4 is bigger, so 4 should be negative. Now if we check the calculation part, 1 minus 12 minus 11, 2 minus 6 minus 4, 3 minus 4 minus 1. Here for middle term, for x nothing is there means 1. So x coefficient is minus 1. So here minus 1 is there. This third pair is the correct pair. So now the first term as it is 3x square. Second term is replaced with plus 3x minus 4x minus 4 as it is. Now from the first and the second terms we can remove 3x common. So remains with x plus 1. Here also we need to get same x plus 1 only. So for that observe the third term. Third term is minus 4x. Already x completed inside of the bracket, so remains with minus 4. Here x plus 1 is there, here x plus 1 is there, write it one time x plus 1, and here 3x is extra, write that 3x here, and here minus 4 is extra, write that minus 4 here. So the factors we got are x plus 1 and 3x minus 4. Now let us find out the zeros, that is x values. X is equals to, here plus 1 is there, so minus 1. X is equals to, here minus 4 is there, plus 4. Here multiplied by 3 is there, so divided by 4. 3. So the x values or the zeros of the given polynomial are minus 1 and 4 by 3. One let us take it as alpha and one let us take it as beta. So alpha equals to minus 1 and beta equals to 4 by 3. Let us do sum of the zeros first. Alpha plus beta equals to, alpha is minus 1 plus beta is 4 by 3. Minus 1 can also be written as minus 1 by 1. For easy calculation I am writing that. Minus 1 into 3, it is minus 3 plus 1 4s are 4 divided by 1 3s are 3. 4 minus 3, 1 divided by 3. So that make it equals to minus b by a. So sum of the zeros we got as 1 by 3. Then coming to the product of the zeros, alpha into beta equals to minus 1 into 4 by 3. 4 by 3 just we are multiplying with minus 1, so this will get as minus 4 by 3. That make it equals to c by a. Product of the zeros equals to c by a. Now moving to the second bit. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. In the first bit what we did, they gave one quadratic polynomial and we find the zeros of the quadratic polynomial, right? But in the second bit what he is giving is, he already himself gave zeros of the polynomial. By using those zeros or sum of the zeros and product of the zeros, we need to find out the polynomial in reverse now. So here he clearly mentioned that sum of the zeros and product of the zeros are given. So first number is sum of the zeros and second number is product of the zeros. So sum of the zeros alpha plus beta, that is first number 1 by 4, comma product of the zeros alpha into beta, that is second number minus 1. So sum of the zeros and product of the zeros are given, then we need to find out the polynomial. For the formula is k into x square minus alpha plus beta into x plus alpha beta. Till the last step we don't have any work with this alphabet k, so just write it as it is. In the last step I will explain what is the work of that k. X square as it is minus alpha plus beta, it is given in the question as 1 by 4, x as it is, plus alpha into beta is given as minus 1. So k as it is times x square minus 1 by 4 into x, 1x by 4 or simply x by 4, plus into minus 1. Now k into, here for the first term denominator not there, for the last term also denominator not there, but here for the second term denominator is there, right? So that denominator you multiply here. 4 into x square, it becomes 4x square, minus as it is, x as it is. Again the same denominator you multiply to this last term also, minus 1 4s are 4, whole divided by 4 now, because every term I am multiplying with 4 also, right? So that's why for all the terms divided by 4 will come. Now observe, in the denominator 4 is there, right? So to remove that 4 we have work with this k now. So take if k equals to 4. Just simply whatever the number will be there in the denominator, that number we will allocate for k value again. So what it will become then? 4 times 4x square minus x minus 4 divided by 4. So here 4 and 4 will get cancelled. Then finally we remains with 4x square minus x minus 4. This is the required quadratic polynomial. Coming to the next one, root 2 and 1 by 3. The first number root 2 is sum of the zeros and 1 by 3 is the product of the zeros, right? So let us substitute in our formula. K into x square minus alpha plus beta into x plus alpha beta. K as it is into x square minus alpha plus beta is root 2 into x plus alpha into beta is 1 by 3. So what we'll get then? K into x square minus root 2x plus 1 by 3. Here for the only third term denominator is there, right? So that denominator you multiply with the first term as well as with the second term. K as it is, so 3 into x square 3x square minus 3 into root 2x 3 root 2x plus 1 whole divided by 3. Now in the place of k, here the denominator is 3, right? So we need to keep 3 only. If k equals to 3, what we will get then? 3 times 3x square minus 3 root 2x plus 1 divided by 3. Here 3 will get cancelled. Then we finally remains with 3x square minus 3 root 2x plus 1. This is the required quadratic polynomial. Next one is 0 and root 5. So this 0 is alpha plus beta, right? Alpha plus beta value is given as 0 and alpha into beta value is given as root 5. So the formula we have is k into x square minus alpha plus beta into x plus alpha beta. K as it is into x square minus alpha plus beta is 0 into x plus alpha beta is root 5. So k into x square minus 0 into anything 0 plus root 5. Now anyway 0 does not have any value, so I can remove that 0 from the middle. K times x square plus root 5. Now total simplification completed. In this case there is no denominator at all, right? So if there is no denominator, just take the k value as 1. So 1 into anything the same number, x square plus root 5. Coming to the next, 1 comma 1. Alpha plus beta value is given as the first number 1. Alpha into beta is also 1 only. So let us take the formula first. K into x square minus alpha plus beta into x plus alpha beta. K as it is into x square minus alpha plus beta is 1 into x plus alpha into beta is also 1. K into x square minus 1 into x plus 1. In this case there is no denominator, so just remove the k value. So we will get x square minus x plus 1. This is the required quadratic polynomial. Question number 5. Minus 1 by 4 and plus 1 by 4. Alpha plus beta value is given as minus 1 by 4. Alpha into beta value is given as plus 1 by 4. Substituting in the formula, k into x square minus alpha plus beta into x plus alpha beta. K as it is x square minus alpha plus beta is minus 1 by 4 into x plus alpha into beta is 1 by 4. So next is k as it is x square minus into minus plus 1 by 4 x plus 1 by 4. Here both the denominators are same, right? So this denominator just multiply with the first number also. So we will get k into 4x square plus 1x plus 1 divided by 4. Here the denominator is 4, right? So take the k value as 4 to cancel that. If k equals to 4, 4 into 4x square plus x plus 1 by 4. Here 4 will get cancelled. Then finally we remains with 4x square plus x plus 1. This is the required quadratic polynomial. Coming to the last question, 4 comma 1. Alpha plus beta value is 4 and alpha into beta value is 1. Our formula is k into x square minus alpha plus beta into x plus alpha beta. K as it is into x square minus alpha plus beta is 4 into x plus alpha into beta is 1. K into x square minus 4 into x 4x plus 1 as it is. Here there is no denominator at all, so just remove the k and write the remaining as it is, x square minus 4x plus 1. This is the quadratic polynomial which we required.